clear the burn head interlock.
And it'll change your,
I want to bleed the gases so we get, hopefully, the nitrous oxide bleeds into it. Go out for us. Now, I didn't open up the purge, but while that's bleeding, it always says no air pressure, no fuel pressure, whatever. I showed you what it
oh
looks
yeah,
like
use
back here.
the T.
Yeah. You hear it? It's very back there. Hear a little bit. Yeah, keep it positive pressure. This environment is not moving.
I was gonna say, you don't need that. But it's
But
just.
you've had it, and you had everything here, so I hooked it up. But I go to some places where they manufacture stuff, and you can look out in. This would be right off an assembly area or something. You look out and you can see this blue haze everywhere. And it means I have to watch the optics, often. So we'll hook it up to purge with this. And that way, what's in the environment's not getting in there because it's sucking air through it. So let's tell it to light it. I'll switch over.
And does it do the same as the other one where it lights the acetylene flame and then it
Yes.
switches over?
Right. Now I haven't told it to switch yet
Oh, I see.
because
Oh, you
copper is-
actually physically, yeah, that's true. Copper's in
yeah,
stainless,
copper's
right?
yeah.
And so then when you switch over,
It'll change.
it's split.
Yeah.
Does it do the same thing where it looks
Yep.
like it sucks down and
Yep.
comes out as split?
Oh, I didn't hit apply. Yeah.
That's so cool.
Till the head gets warm, and then that V will, because what happens is the head has it's expanding, so it's like this, and as it gets larger, it comes back in. So remember, you don't adjust the nebulizer on nitrous oxide. Not that you can't, but you're affecting the uptake rate and the temperature at the same time. So you typically adjust the uptake rate with something that's not nitrous oxide, and then adjust the temperature with the oxidant or fuel. Now, this flame is not a typical nitrous flame because we don't have any red in it. So we need to give it a
Because
little
we
bit
don't
more
have enough
fuel.
gas?
So I'm going to do it one click at a time. Let's go 2 clicks this time.
There's the red.
We start to get red, and then what we're going to do is we're going to get about a 1-inch feather, and we don't want any white because it starts building up the carbon. So what we would do is go about right there. Okay, I would start there. Okay, and then right now, if I was running nitrous oxide element, I would go to continuous graphics, and I would, once I've got that, I would start dropping the burner head because now we have the light right at the top of the head. I want it up there, so I would stop. I would watch for.
Oh, yeah, because you want it in the red zone.
Yeah, I want it at the top of the red zone because nitrous oxide said I'm temperature sensitive and I need more temperature. I got 33% oxygen versus roughly 20 for air. The same thing it does for a car. It helps it burn hotter. So, and then continuous graphics, as I drop it, I will see the dormants go up, and I'll get to a certain point, just like any of these adjustments, that I'll start to see go back down again. I'll come back to that point, and then I'll make 1 or 2 clicks, one way or the other, for flatness. Do I get maximum sensitivity?
Yeah, it's fluctuating a lot.
Now what? And plasmas and all flames do. What's this? actually had to add
Yeah,
more.
you cut it down.
Yeah. So,
Wow. You smell that.
yeah, so I'm getting back to there again, but what's what happens if I pull water out? Up there. So it makes a difference, you know, when you're actually,
When you're pulling
When you're
versus.
pulling. and then when I get to where I've got wine in it, I've gone too far. I don't care if you have good sensitivity. You're gonna have problems with the carbon building up on it.
Right.
So back off from that. What you want is, you want stability, and actually the little carbon flex, call them burgers. I can't believe it. So anyway, they'll actually, where they'll block the head, so you'll lose sensitivity. But, you know, that's a good place to start. But now we know that
You know the nitrous works.
yeah. So we'll go back to air. Now I've got the.
Yeah, too much fuel.
Yeah.
And then back it down.
There we go. So, now, if you're gonna run things, with the air settling on this, you run it richer, because what it will stay lit, and you'll get better sensitivity there, because just the velocity of it. So it would be a taller blue than what you would on a 4-inch head. So what we're gonna do now is we're gonna give it the test. It's got an air volume in it, so when the solenoid goes out, it's got a tank of air, so it burns up.
Gotcha.
I didn't do that either, so.
You just ran all your final tests?
Yeah, we did. So we'll turn this back on. All right. Now, eventually.
I was gonna say, the instrument didn't even, oh, there it is.
Yeah. Eventually, it will say it when it tries to go do so. Every so often, it goes and pulls the instrument, for lack of a better word. So, I don't think you're going to have room enough for that in that length there.
Yeah, I can get them to
Yeah.
shorten it.
They shorten it. Now, I'll need. It needs to be right there.
6-inch clearance.
Well, yeah. Well, yeah. Give it about 6-inch length. That way I can get the top off. Without moving the instrument, because when I move the instrument, then I gotta move the furnace too. So.
And it's not on. You've been running it all day, it all down now.
The what? Oh, the vent?
Yeah,
Well, you got big enough room there, I didn't notice it.
yeah, it's on there.
If we were in a small room, you'd feel the heat build up. Okay, now let me show you what you can do to make it talk to it again. You go, okay. I double clicked on here, brought up flame. I say, reconnect. It says establish connection to it. It says it's not connected. It's not far enough into its power up. But that, click on that, it brings up the spectrometer and the flame. Oh, and also spectrometer over here. You click on this, and it tells you if you have problems, red, X, or something. If the slit, prism, or the grating, or the gas control was the issue.
It's still doing
It said, okay, but I remembered that I had interlock. Yeah. Yeah, the interlock was you had no power. So we're
chip. It's got green chip. Then you can see that's where the base module is where it picks up things. It said we're running right now a copper demo. We don't have any sample information file.
And the data set we're saving to is demo.
So now we're going to, let's see, we talked about the method, sample information file. This is analysis. If you want to automatically export things, go here and you can we have
Oh, so your form templates for
Yeah.
reports.
for Excel. That's it will Excel recognizes that file. But also go here. If I go into here and I go to manager, like this. This is our database manager, and we have library categories results and where it's being, we got methods and results.
Oh, that's right, but then
Yeah.
anything about the-
Yes, this is the only place you can delete methods. But really, the big thing is results, and you can go into a report. Okay. So let's go to demo, and we go report, and this is our, we come up with designs, okay? And that's where we design an estimate for. Okay. So I go create a new design, and I can tell them I want it just like it was chronologically. If I get it chronologically, it looks the same way as it did. I tell it by sample type or alphabetically, or if I've got a lot of things by date or whatever. And then I go preview. That's what we want. I just ran that properly. And the standard was and came back and read it. So that's your report, and the reports are in the data manager. That makes sense. Now, let's talk about things that, when this thing gets full, we would want to archive them somewhere else. I would highlight it, and I would say, I can do two things. I can copy them, or I can archive them. And the archive is zipped. The copy is unzipped. And it's typically easier to copy them and then remove them out of here, because then you can go back in the software and then do your reports without zipping them. You got to see that in a zip file, you gotta unzip it.
Now, do you want to copy it or archive it, so it would, else kind of
But,
drive?
but
kind of
yeah,
thumb
but you
drive?
take, it will,
You tell it.
you tell it
where
where
you
to
want
put it,
it.
yeah. So if I said, I want to archive this, okay, entire library, and where do you want to put it? It's a zip file, okay? So if you wanted not to use an archive file, you can tell it, you go click here and you go put it on thumb drive and or in this directory or whatever. Okay. Or you can go copy, and you see, I'm giving anything back up, whatever. It's not a zip file. So what you typically do is, because databases, you all, you're not running the software, but in industry, you run it every day.
Yeah.
So what will happen is, every time they call up something, it's very slow to respond. It's got to pull up the whole database. So so I know that then they haven't done any of this. So what you typically do is archive or copy it somewhere else, and then delete it from here, and then check it. Okay, along the order, as you did before. You check it, because once you defrag it, if there's an error, you can't do anything about it. So you're going to copy it, delete it from here, check it, and then pack it. Packing is defrag.
Archive or copy,
Then delete it, then check, then pack. They used to have it in the opposite, it was always real spotty. But just think of hack is defrag. If you know how a hard drive works, it's got a file allocation code on here, and once you defrag stuff, it doesn't know where anything was before, it just puts it all continuous. So this is data management, results, and methods. That's it. Kind of let you know what's going on with this. We use a software. Yeah, software that sits in between it. And if it can't talk to the furnace and the furnace is on, you go over here and then you go, wow. You click on devices, you don't see one there. And this board's not working. And then you can right click on this one and it says troubleshooting utility and go in and try to talk to them. So I always put that out there for that reason. So offline, to kind of give you an idea of offline, we're kind of jumping through all this. Can't really see it unless I'm here. What all you got, you have nothing to do with lighting the flame or anything like that. Controlling everything, you can't set anything up. Offline you can do everything but edit what's currently running. You don't.
can be running samples, if you had an auto sample, you can be running samples,
Right.
and then go into the offline and work up
Yeah.
previously.
Sure.
So this would be more useful for the graphic
For the
furnace.
funds, right. So you do not want to modify or touch the database it's currently writing to or the method it's currently using. Any two other are fine. Just, you don't want to mess with stuff that it might be trying to write to.
That's why you can copy stuff out of your database before you start.
Absolutely, yeah. So you can be creating methods, be doing all sorts of things. You can be getting reports. So it's offline. Another one in our ICP aspect, they call it instrument control and offline. So we're back here. Now we're going to go to techniques. We want to tell it we want to go to funds. And then we don't want to change the sample programs. Save method. What is gas flows? So it's going to shut it down, bring it back up. Now while it's doing this,
We can be swapping out.
yeah, so first thing we're going to do is we're going to pull the sample tray off. Yeah. Make sure we're looking at the right spot.
Yep, we're looking at the
Okay.
flame head.
So the sample tray, we just raise up and then it comes right out. Now, we'll set this right here for right now. These two look like they were married together. It's got, it does. It's, this Finnegan, it's got the nice little round spot right there just for it. So to get the flame out, do this. I'm going to set this right up here for right now. And you want to do it? Raise up on that pin. Okay, and then you can push it back. Go all the way back. It's not too heavy. And I didn't know where you wanted to set these.
That's as good as
Yeah. So to get this in, we're in the lock position, I have to pull it out. And then we'll swing around.
Is there a reason?
No, pull it on there. Now watch, see this thing right here? It has to go, so I have to, we got a lot of weight out here, so when I get close to it, I'm gonna raise the, feel it sliding back in there. When I get close, then I raise on the front. And then till it.
Because I gotta, okay, this doesn't plug into that.
There we go. What it is that pin
Yeah.
hitting that slot, and just raise on the front, goes in. And then these. So, it has changed techniques. It has the last method I used, which is a characteristic mass one.
Yeah.
Okay. It looks basically the same thing. But now instead of flame control, I have furnace. And this is referred to as a workspace. Okay? So, it's real simple. It's the same thing. So let's talk about what it takes to align this furnace. So we're going to go to analysis, new method. We're going to check that we've got the chrome. We haven't checked about that lamp yet. Okay. So we're going to go to settings. 3 5-second readings, that's fine. And these are the default temperature. Okay. Petri dish, is that what it's called?
Oh, watch glass.
What, okay. I used it to check your drying, and it's drying good. So this 30 second, it was almost dry at the end of 110. The difference between 30 degrees or 20 degrees at 2500 is nothing, but there is a big difference with drying. And what happens is when it's not drying away, you don't get reproducibility. And so sit and watch it dry, and if it's not drying correctly, then your contact cylinders are wearing. Contact cylinders only make contact at the very, very end zone. So, if you look down into the conical shapes, and if you look at the tubes, they have a bevel. So they only make contact right there. And you're really talking 1.9 volts at 1200 degrees. Voltage is synonymous to water pressure. Okay? So if you have a high resistive contact, then it's not going to. If it's 1.9 at 1200 when it's drying at 100, it's not enough to push the current. But low voltage with a lot of current. So if make it synonymous water system, voltage is water pressure, current is the water. So when it gets where it can't dry, then you've got little grooves in here where it's not making any contact. So that's an indication that you need to change contacts. And it's totally different now. I grabbed one of yours from the other because I like this better than the same now. So it'll be a long time before you have to do that. And then, while I'm talking about it, all our software has active window help. Press F1, talks about furnace program. any window that you have a question about, if you want to go index, you go,
Search on it.
yes. Don't tell you how to do it. I'm trying to contact someone.
This will, you got a user's guide, and go back somewhere, here you go, talks about the tools right there. How to get them running. Kind of followed what you had there.
Yeah, that's,
Yeah. Furnace is here, flames here. So, typical program there. Auto sampler, just like your other one, it could pick up different volumes, so you could make your auto sampler make other standards. If we have a 10 part per billion, and I want to make a 2, make a 2.5,
right.
and a 5 out of a 10, you know, do it from here. Matrix modifiers, and you're all still remember that about, okay.
I haven't used it for myself.
Okay, yeah, the difference is, when you go to recommended conditions, the difference between flame and furnace, it will tell you, what you should be using. This is magnesium nitrate, okay? So you'll probably want to get you some matrix modifiers. And in our catalogs, right here, and we go to the AA part, it talks about graphite and matrix modifiers that you need. Right here, I think we went right to it. Right there. They'll tell you how to glue them down. You generally put 5 microliters in there. And what they do two things. Either make it temperature stable enough to where it will, you can take it to a higher charring temperature and not lose it, so that you get rid of unwanted stuff, or it makes it easier to analyze. So, you tell it where your matrix modifier is. Typically, things that you're going to add to everything, you put in the big ones. Your standards, any kind of QCs, matrix modifiers go to the big ones. Now, you know what? You got two different sets of yeah, some more
Oh,
samples.
so we can use
Yeah,
2 different file
yeah,
sizes.
and they sent you,
I had a book
these are what you.
Yeah, I had a ton to begin with.
Yeah, and these
Oh,
are
and they
the
sent me the,
small.
okay,
Yeah.
good.
So I was trying to think, well, I hadn't even found out in this software where I tell it,
What the volume?
yeah, of which ones I'm gonna be using.
Well, does it matter? Because it's.
Yeah, because they're different size. You have to tell it that you're using it because it won't know where to go.
Oh, to
Yeah.
address the auto
88 samples, I can't remember what that is versus 148. So,
So is it? Well,
you would think it would be under instrument, condition furnace control, open to close, on tip. There we go.
There it
Under
is.
devices,
Okay.
whichever trade you want to use.